So I'll talk about how future is coming up, and one of the big things changing future is obviously the net. Whether it's Google or your Facebook or Twitter, you are seeing that the way people behave, the way people interact, the way people now educate or collaborate, or as I'm going to talk about simulate later on, is going to be changed with the availability of computers and communication technologies together. We say in short IT, but really IT by IT we mean the net now, or World Wide Web or internet now. So we'll see how internet will shape our things. But let me first summarize what we learned so far. India is definitely has arrived on the world scene as the biggest manufacturer or second largest manufacturer of castings, okay, with 8 million tons per year. And we need the foundry industry to forget about exports. For our own big domestic requirements of all kinds of applications which you have seen, we need that for that. And we are also being preferred as exports in many segments. In fact, Sundaram Clayton mentioned and others mentioned that we have been GM Supplier of the Supplier Award. They won in several years in a row. We are winning quality awards in many ways. People are recognizing us, that saying, okay, they are a good combination of frugality with quality. Indians are good at that. So we have been recognized in many ways as being good in manufacturing. And also remember that we have a large number of foundries, they employ a large number of people, and they are also SMEs, so SMEs have their own important role to play in the society and the economy and country. So not to forget about the importance of industry in this. But we also seen that we have two major issues. The major issue is the quality. We are not able to supply the expected quality by the customers. Perhaps we have too little automation, perhaps we are taking too much complicated orders, perhaps our combination of metal process and design are not compatible. Whatever reasons, end of the day, our rejections are way too high, and that has to come down. Okay, whatever reasons and excuses we can give. But the major challenge, how can you get a good quality without a good qualified manpower? And manpower, wherever you go in foundry industry, any meeting, any forum, any conference, someone will say that our major issue, major challenge is manpower. Everyone says we have this huge country, huge population, but we don't get people to work in a foundry. So this dichotomy or this funny reason is quoted all the time in the country. So when you go forward, we have to keep these at the back of our mind. We've also seen in this course how CAD and simulation can help, and not to forget that methods design is a critical middle step which people ignore in simulation. You cannot do simulation without methoding first, and methoding is driven by the part design. And what you have seen is some of those good ways or good practices for a perfect mold design, perfect gating design and feeding design should help you to do better simulation in a faster time at a lower cost. We also seen benefits in terms of numbers. We said number of trials can be reduced by 75%, your rejection can be reduced by half, and your yield can be improved by about 25%. And these are all average numbers arising out of people who are using software in India. These are numbers we can achieve. So these are the targets a typical foundry can achieve. And we are saying this out of a lot of experience. We have done hundreds of simulations over the last 5, 10, 15 years. Increasingly now we are doing it now day after day, month after month. And now we are doing it no longer by ourselves, but we are now taught others how to do simulation using whatever simulation tool they have got. So with all this experience, we also looked at some of the best practices. How do you get the quality right? How do you get the high accuracy results as fast as possible, and so on. We mentioned in passing that simulation is not about just those yield and lead time and rejection quality improvement, but also there are a lot of intangible benefits. And let's look at that quickly. Cost reduction. For existing casting, you can improve the quality and improve the yield. That is one. And new castings, you are reducing development time and can have a lot of intangible benefits, including your image. That is also known. Now, one of the examples we have seen, because now we have CAD and simulation, you are able to try something new for the first time. Take up a new challenging order, or take up an area which is giving you high value addition, or explore some new niche market segments. A CAD simulation also forces you to have data on the disk. You don't have to write any more handwritten notes. Data is already there, CAD drawing is there, notes are there, simulation data is there. You are making PowerPoint presentation to send to your customer. It automatically has captured the knowledge and data which is useful for your ISO 9000 if you are particular about it, but more important, it's a starting of the technology database which you can use for your own future projects, and that's very valuable contribution from CAD and simulation applications. The last one, which also we've seen in passing, is it changes the culture in a foundry. Okay, it is great for, one is you get to see a better, faster, logical decision making. It improves the way people interact, especially the way juniors and seniors interact, and it becomes a starting point for attracting and retaining new talent, especially younger talent. A younger guy passing through a foundry and seeing a CAD room, I'll tell you immediately he has made up his mind that okay, it looks like a nice place to work. Okay, it's a starting point of a better relationship with your employees, your own employees. What we have been doing over the last, again, 10, 12 years is to popularize this, because IIT alone, because of the location and the time and other constraints, we cannot be reaching out to the rest of the country. So we are now slowly spreading out by setting up what I will call as local expertise or local resource centers. And you will see these centers in both academic institutions as well as R&D institutes as well as foundry clusters. So Institute of Indian Foundry may have set up now 2-3 clusters now. One is, first one was in Hyderabad, second was in Belgaum. Okay, Hyderabad now they extend to one more. Similarly, Coimbatore, other places, they're setting up these cluster offices where you have a local person trained by us and in continuous touch with us. So instead of we supplying the knowledge or expertise all the time, you are now local centers of excellence. Okay, and they have access to us to help the local foundries and maybe students also. Okay, so these are some of the centers coming up. We still have little pockets left in North Gujarat and maybe Rajasthan and maybe in Punjab we don't have too many, but we are looking for local champions who would like to help us to start a center there, and we are ready to transfer all the knowledge and all the tools and experience that we have got to them so they can help the local people there. We are now Bangalore is directly from that company. This I didn't mention a company called 3D Foundry Tech. They themselves have Keshamurthy, if you have seen him yesterday, he is from Bangalore. So he is a direct person there at this point of time.
If you want education institution, you can refer.
Yeah, please do actually. See, finally, end of the day, you have to find one champion who will take it forward. The director may say, yeah, we're interested, but finally, the actual job is done by one faculty member or some researcher who is interested and passionate about it. If you don't find that person, I'm sorry, we can't do anything much. So you need to find that one person who is passionate about his industry. Then I don't mind. I mean, then absolutely great. Other things we have done is to create nice course content, and you have seen example of the course content in terms of teaching material and laboratory material and industrial case studies and so on, and the slides material, all of which can be used by teachers for teaching and students for laboratory exercises. We have now installed the software in a large number of education institutes, and they do this step by step, either at a UG level maybe one lab, at a PG level maybe 3 days, 3 turns, what they call as lab turns. And here you see actually in a Vijayanagaram college, if I remember, Maharaja College, Vijayanagaram, remote areas we have done and install the software, and they have using that for their lab exercises. We also have done a lot of clinics. Clinics means, you have seen an example of clinic yesterday afternoon, where you bring your problem. Ideally you send the problem a day or two before so people can check the formats. Sometimes the STL file is not correct, or methering data is missing, or photograph should be there of cut section. So these data has to be checked, but eventually it is a live session where the consultant and the participants are interacting. You are trying out different methading options, you are trying which is better than that, or at least you are finding out if there is a defect, why defect is happening. Is it because feeder is too far, or feeder is not correct, or some padding could have been put. So you are getting a troubleshooting and some basic direction of solution. So we do these clinics, and over the last 3 years we did almost 20-22 clinics now. Now I'm not doing any more because I think we established the process, and at least but now clinics continue. But what you're saying, Professor Kuthe, for example, he is now willing to start a clinic organize a clinic in Nagpur. So I said, by all means do it. And then he himself is now, he's learned AutoCAD. He's actually spent 3 days like a student here. Actually he is very knowledgeable person. He could have taken the whole 3-day session by himself. So I'm saying do it, you do it in Nagpur, and if you need, I'll be there on a video link. Okay, so we want to see that the knowledge spreads out to the rest of the country. So where do you go from here into future? So one is in two-line statement of the problem, which I am putting as a national problem. We are seeing that there are less than 5% foundries use simulation, directly or indirectly, whereas it is about 60-80% in the West, Europe and America. The potential saving is almost 5 to 10,000 crores if you look at both tangible and intangible benefits. You're talking about 5-10,000 crores per year benefit to foundry industry, and not even talking about benefit from that flowing into OEMs and other places. I'm not looking at the fuel saving of the cars because there's a less weight of the car casting. I'm not looking at that, just direct measurable benefits at foundry level only. So the challenge I'm posing to myself and as a country is, can we take the penetration of simulation in Indian foundries from current 5% to 50% in the next 5 years? Can we do it? Okay, that's a huge challenge. Okay, as a country we have a huge challenge, 5 to 50% in 5 years time. Can we do it? We thought a lot about it. We cannot do it by the way we are going, at the speed at which we are going. We cannot do it that way. The only hope is to leverage the Indians' inherent capability in information technology. Okay, today if you go to any of the CAD companies in USA, whether it's Pro Engineer or SolidWorks or any Autodesk, and if you walk around, you will find that they are Indians. Every other person is either a Narayanan or a Mehta or some Shah or something like that. So every third guy is an Indian there. Okay, and if you go to Bangalore and Hyderabad and Pune and all those engineering research centers, you will find that we are doing massive amount of export of engineering services, very high value engineering services to companies like GM and GE in the West. Okay, so today we can proudly say that Indians are developing software and they are providing engineering software solutions. Okay, but you can say other way around, it's also bad news. We are developing software, but we don't own the copyrights of that. Okay, and we are providing solutions, engineering solutions, but to the MNCs or Western companies, not to our own industry. Okay, so that's, we can also say it's in a negative way. So idea is, if we can leverage Indians' capability in IT, and remember that every time I take a flight through maybe Amsterdam or Frankfurt, and someone will come and say, the moment now they know that you are Indian, so they say, oh, by chance are you working in Infosys? As if all Indians work in Infosys only. They assume that Indians must be good at IT. I'm only afraid he won't come and say, I have a problem with my laptop, can you fix it? So I'm almost afraid that he'll say something like that. But so with that, so it's IT is in our blood. Geometry and mathematics, all said and done, we have it in our blood. Okay, we are good at that. So with that, can we take it and leverage it for our foundry industry? So we are saying, can I visualize an online system for education and collaboration, which is needed for DFM and for simulation on the web? So what I'll give you a quick glimpse of these three in the next few slides. But before that, let me just tell you how it started, how I got the brainwave. So one fine day, there was within a week there were two different calls. One call from Chandigarh, one call from, in this case, Sundaram Clayton from Chennai. They said that we have an urgent problem on the shop floor and we want you to fix. And we know you can fix it, don't have argument. We are sending the air tickets to you, please come immediately. Can you come tomorrow? Okay. Now they assume that, okay, they send air tickets, I will cancel all my classes and all my meetings here and everything like that. I'm sorry, I'm just exaggerating the joke, but I mean, we have a busy life here. I mean, people forget that faculty have extremely busy lives. So I said, I have no problem coming to Chandigarh, but I cannot come tomorrow. I can come maybe next weekend or something. I said, no, we have totally urgent situation on the shop floor. Please come immediately. So that forced me to think and innovate and said, okay, let's try something different. So then I discovered that there's something called as a GoToMeeting on the net. And GoToMeeting is simply a website, and you can download the software free of cost and it will run fine for 1 month. After that, if you want to use it, you have to pay $50 per month, which is not much, 2,500 rupees per month. By doing that, the beauty is whatever you do on your computer screen will be visible to the person somewhere else, anywhere in the world. So I told Sundaram Clayton in this case, okay, let's do a GoToMeeting. And we scheduled next day 11 o'clock. I remember it was 11 o'clock next day. So what they did was and this was, I should acknowledge Dr. T.V.L. Narasimha Rao. He was the head of PhD in a foundry, okay, in Sundaram Clayton Foundry. So he said, okay, let's do it. So he had his mobile phone camera, he takes a picture of the casting and then sends it to me, and then I see the picture of the thing on my screen, and he sends a STL file of the casting to me. I do simulation. As I'm doing simulation, he is able to see the simulation on his computer screen, and he has two other people, the foundry and quality person there. And then I said, okay, fine, looks like there is a hot spot somewhere near the bump there. And I said, do you have a cut section of that? He said, no problem, you just cut the thing and then immediately send me, again mobile phone camera, and then immediately he sends the picture of that, and we match the result in that exactly same place we are getting a defect. And then I said, okay, what do we do now next? So I said, okay, a few things, and I can't show you all the results here because it's perhaps proprietary, but we tried putting some chill somewhere, a cooling channel somewhere, and there's no hope of making any part design change, only shop floor emergency situation. So we did a little bit of shop floor methoding changes, little bit of cooling and chilling and all that, and the problem was solved. How much time it took? 1.5 hours. 11 o'clock we started, 12:30 the over, session is over, bye bye, good day. Okay, I don't think they paid me anything for that. I don't remember any payment for that. I don't think I got paid for it, but I'm happy about it. But because of that, I said, wow, I mean, I don't have to move from my desk, and I've saved 2 days of at least 1 day of travel, and travel is a pain, you lose half a day before, half a day later. So with that, we said, great. So can we use IT to our advantage? And I will summarize now, but I'll call after this to give you a glimpse of the online education, simulation, whatever, how it's going to happen. But I want to now close session because otherwise mic changing takes too much time. So if you remember, we said global leaders, low cost is China. Productivity per foundry, we said Germany is number 1. Value addition, USA is number 1. And we said Japan is known to have high quality, at least today. So question is, what will India do? So I'm saying, can you think about saying, if anyone wants a complicated casting delivered fast, if China can do it in 1 month, can you do it in 10 days time? Okay, and I'll tell you it is possible. Okay, you know it is possible, I know it's possible. You have to just say, we will do it, and then if you once set your mind, because we cannot do it unless you leverage IT. Right from the first time when you exchange your drawing to send the quotation, to send him the simulation results and say, please okay that, and you use RP perhaps to make the tooling, and then pour the casting, what 1 week, I can do it in 3 days time. The Ganesha picture which you have been seeing on your screen all the time, the entire steps including 3D modeling of the Ganesha, okay, was done in 7 days time. And 3D modeling Ganesha is pretty complicated, please remember that, right, including CAD modeling, not after drawing, including drawing, done in 7 days time. So we can actually do it if we set our mind to that, except the way we'll do it, if West can be innovative, we can also be innovative in our own ways, we know how to use IT. Okay, so I'll kind of close here.